Hey everybody, welcome back. You might remember that in the last several class meetings we've been talking about how to model fraction division. So today we are going to work on dividing fractions without modeling, and we're going to use something called the standard algorithm. So if you look at our learning targets for today, you see that one of them is that I can use the algorithm to divide fractions. So algorithm just means that you can use the standard math to solve a problem. So our learning targets for today are I can use my understanding of multiplication of fractions to explain division of fractions, and I can use the algorithm to divide fractions. So what we're going to do today is we're going to fill in this little chart that you've been provided. So let's first go through the steps whenever you want to divide fractions. Step 1 says convert whole numbers to fractions. And it says do this by, so you might already know this, but if you don't, you can take any whole number and turn it into a fraction by writing the whole number with a denominator, and I'm going to abbreviate denominator, of 1. So if I have a whole number, I can write that as a fraction that has a denominator of 1, and that turns it into a fraction that I can work with. Step 2 says find the reciprocal, and if you have been following along with the activities that we've been doing the last little bit in class, then you know that a reciprocal is a number that when you multiply it by a fraction, it gives you a product of 1. So the reciprocal of that number ends up looking something like this, because if I have 1 over 4 and I do 4 over 1, 1 times 4 is 4, and 4 times 1 is 4, and that equals 1. So for a shortcut, we say that the reciprocal is just the flip of a number. So notice that it says find the reciprocal or the flip of the divisor, which is the second number. So you're going to see what that looks like in just a second. Step number 3 is you replace the division symbol with a multiplication symbol. And then step number 4 is you multiply across your fractions, just like we've been reviewing with fraction multiplication. And then step 5 that we always try to do is simplify if possible. So we're going to do some examples together in your chart today, and I want you to pay close attention and make sure you're doing this. The first example is a fraction divided by a fraction. So we have two fractions. We have 3/5 divided by 9/10. So my instructions were to convert any whole numbers to fractions. Well, in this one, I don't have any whole numbers. So this is going to stay as the same problem. Step number 2 is find the reciprocal of the second number, which is known as the divisor. So that means 3/5 stays the same. We keep that number as it is. We flip this number to its reciprocal. So instead of saying 9 on the top and 10 on the bottom, it now says 10 on the top and 9 on the bottom. Step 3 says we replace the division symbol with a multiplication symbol. So I keep my flipped fraction, 10 over 9, but instead of a division, I now have a multiplication. Step number 4 is I multiply across the fractions. So this is what it looks like. So 3 times 10 we all know is 30, and 5 times 9 is 45. Step number 5 is I look at my fractions and I see, can I simplify that fraction? And this is a review skill for us. So we try to see if we can identify any factors that the numerator and the denominator share. So if you look at 30 and 45, your first thought might be 5. So if I simplify 30 by dividing it by 5, that means that gives me a 6. And if I simplify 45 by dividing by 5, that gives me a 9. Well, I stop here and I think, now, is 6 out of 9 in simplest form? And if you think about 6 and 9, they are both divisible by 3. So 6 divided by 3 gives me 2, and 9 divided by 3 gives me 3. So this is the answer for my division problem, 3/5 divided by 9/10. Moving right along. The next one is a whole number divided by a fraction. So for this one, I'm going to take this whole number of 4 and I'm going to turn it into a fraction by writing a 1 underneath it. So this is what my problem looks like now. Notice it no longer looks like a whole number. Now it looks like an improper fraction. And then I'm going to do 4 over 1. I keep it as the same, and I find the reciprocal of 2 over 3. So when I flip that, it becomes 3 over 2. Now I'm going to leave my numbers as they are, and I'm going to replace the division symbol with a multiplication symbol. And now I'm going to multiply across my fractions. So this is what it would look like. 4 times 3 is 12. 1 times 2 is 2. It doesn't take long to realize that that is an improper fraction. So if I want to simplify 12 over 2, I ask myself, how many times would 2 fit into 12? And most of you probably know that that fits exactly 6 times. And I don't have a remainder, so that means I don't have a fractional part. So my answer for this one is just 6. And our final example says 7/8 divided by 3. So this time we have a fraction divided by a whole number. This number remains the same, 7/8. 3 can be turned into a fraction by putting it over 1. So then my next step is I leave the first fraction, I keep it as it is, I flip this fraction to be 1 over 3. Now I'm going to change my division symbol into a multiplication symbol. And then I'm going to multiply across my fraction. So this is what it looks like. 7 times 1 is 7. 8 times 3 is 24. So then I ask, okay, can I simplify 7 over 24? If I look at that problem, I see that 7 only has a factor of 1 and 7. 24 shares a factor of 1, but that wouldn't really help me. And since 7 does not work with 24, then that means that number is simplified. So the answer for this one is 7/24. I hope that this has been useful for you in helping you to review how to divide fractions using something called the standard algorithm, which means without drawing a model. I would like you to now cut this to fit into the correct page on your notebook. And then you're going to get a set of questions that you're going to need to cut and glue onto the next page of your notebook and solve using what we call the algorithm. So set up an equation that matches the problem and then solve it without drawing a model. Thanks.